Alright, I promised you I'll make a video on this news vendor model problem. Let's work with the same problem that we started in the class. Suppose this newspaper guy can buy the newspaper at, say, let me use a different color here. Suppose he can buy it for 50 cents, so its cost is 50 cents for him. So he can sell it for $2, and if he cannot sell it at the end of the day, he can return it back to the wholesaler for 25 cents. So in this case, for him, the cost under his cost, the cost of buying one less unit is what he could have sold it for, that is $2, minus how much it would have cost him, that is 50 cents, is $1.50. So if he orders one less unit than what is being demanded, he loses $1.50. What that means is if he sees a demand of 51 but he only has 50 units on hand, he really loses $1.50. That's the cost of having one less unit. CO, the cost of having one extra unit, that is, suppose he ordered 50 units but he only sees the demand of 49 units, he loses. So he would have bought it for 50 cents and he can return this for 25 cents. So he loses 25 cents, right? So the cost of ordering one extra unit, that is one extra than what you would have see the demand of, he loses 25 cents. So let's put this on the side, right? Until now, what you've done is, suppose this, for every problem, and that was the purpose of your whole statistics class, is we see demand or a lot of random variables in terms of distribution. Suppose this guy knows that his demand follows a normal distribution with a mean of 100 and a standard deviation of 20. In the absence of this information, what you would do is you would go with the mean, right? The mean of 100. But that's not fair, because mean means the middle value. Taking the middle value is not a fair idea here, because if you order one less, you lose $1.50, right? If you order one less, you lose $1.50. But if you order one more, then if you're wrong on the more side, it only costs you 25 cents. Mathematically, how do we go about doing this is we use these two formulas. The first one is what we call the critical ratio. The critical ratio is CU divided by CU plus CO. So CU in this case is $1.50. So $1.50 plus CO is 25 cents. So this is $1.50 divided by $1.75, which comes out to be $1.50 divided by $1.75. $1.50 divided by $1.75 is about 0.86, right? Comes about 0.86. So how do we interpret this? The way of thinking of this is, think of this value as the one in the normal distribution table. That's why I have the normal distribution table here. Find the value 0.86. Okay, it's not in this page. Let me go find if it's in the next page here. So if we look for 0.86, here, 0.86 is, say, well, I guess about here. It doesn't let me write for some reason, but you can see 0.86 being around at 1.09, right? 1.09 in the positive side. So what this is saying is, so our Z is, the equivalent G for 0.86 is 1.09. So you have to order mu equals to 100 plus G equals to, let's just take 1 for the to make our life a little simpler. Sigma equals to 20. So you have to order 100 plus 20 equals to 120. Now let's suppose, just for the sake of argument, suppose this was flipped. Okay, suppose your CU was, let me use a different color here. Suppose your CU was 25 cents and your CO was $1.50. So it will be 25 divided by 25 cents plus $1.50. So that would be about 0.14. That's right. 25 cents divided by $1.75. 0.14. How would this change this answer? Well, let's find 0.14. If you go back to G table, 0.14 would be somewhere, 0.14 would be somewhere, 0.14 is somewhere here, right? Somewhere here, that is minus 1.08. Minus 1.08 is where 0.14 is, right? That means your equivalent Z, let's call this G2, is about minus 1.08. Okay, let's just simplify this for minus 1. As you can see, if your critical ratio is less than 0.5, your G is going to be negative. Then making your Q calculation is mu plus G of minus 1 times sigma of $20, 20 units. So making it 100 minus 20 of, so you have to order 80 units. So this should make sense. Now let me take this away. Take this away. Now this should make sense, right? Remember, our critical ratio is defined as CU divided by CU plus CO. This ratio is going to be 0.5 only when CU is equal to CO, right? In that case, it will be 0.5, and the equivalent G for the probability of 0.5 is 0. If your cost of ordering more and the cost of ordering more and the cost of ordering less is exactly the same, then you have no way to move away from the mean, right? Your cost of ordering, when the cost of ordering more is higher, then you want to make an error by ordering less. If your cost of ordering less is higher, then you want to make an error by ordering more. But if the cost of ordering more and ordering less is exactly the same, your best bet is by ordering in the middle. Now, suppose your CU is higher than CO. As our case in the earlier example, our CU was $1.50 and CO was 25 cents. In that case, the cost of ordering less is higher. So you want to make a mistake of ordering more, right? You rather make a mistake of ordering more. That's why when the cost of ordering less is greater than cost of ordering more, what happens is this value becomes greater than 0.5, right? This value becomes greater than 0.5. As the value is greater than 0.5, your G is going to be positive. That's why you would order more than the mean. On the other case, if your CO is higher than CU, the second example we looked at, we flipped the numbers. What's going to happen is your value, your probability is going to be less than 0.5, right? It's going to be less than 0.5. When the value is less than 0.5, your G is going to be negative, making your value, how much you have to order, less than your mean. Basically, if your cost of ordering more is higher than the cost of ordering less, you want to make an error of ordering in the lower side. That's the whole logic of this news vendor model.